Assalamualaikum everyone, welcome to Mathematics with Shahab Yaqub. We are starting with Algebra and this is lecture number 23 and this is indices. So let's get started with the idea of indices, and before that let's have a look at the syllabus. So now indices is divided into two parts. This is the syllabus for the year 2025 all the way till 2027. May-June 2025 till May-June 2027. Now indices is considered part of numbers, that is arithmetic you can say, and indices is also considered part of algebra. So it's divided into two parts and we will study it all together. Now the concept related with numbers: understand and use indices, positive, zero, negative and fractional. So let me highlight this thing. That is positive, zero, negative and fractional. And these are the examples that are given. Understand and use the rules of indices. So these are the two things that is part of arithmetic, that is part of numbers. When we talk about algebra, understand and use indices, positive, zero, negative and fractional, and that is with respect to a variable. So it's the same thing as part 1 but with respect to a variable. Understand and use rules of indices, again it's the same thing but it is in terms of x. So basically in algebra it's the same thing as in numbers except the fact that we are using it with respect to a variable. So let's move ahead. Now when we use the term indices, so first of all, index, this is the word that we use for power, also known as exponent. An index is basically for a single term. It is a singular word. And when we use the word indices, indices, that is the plural that we use. So let me just stop for the azan. So now we were using the terminology index, that means power. Also the word exponent is used. The word indices is plural. Now what is index or indices used for? For example, if I write 2 times 2 times 2, now this 2 is multiplying by itself 3 times. So we consider this 2 as the base and this 3, because 1 and 2 and 3, that is the power, that is the index, that is the exponent. So in short, it's a short form of writing it, 2 raised to power of 3. Similarly, if I have 3 multiplying by itself 4 times, so now the base is 3 but it's multiplying itself by 4 times, so that is 3 raised to power of 4. So the first example is pretty basic. Rewrite the following using index notation: 1, 2, 3, 4, 5, that is 3 raised to power of 5. And now we are talking about variables also. So now we are studying algebra as well as the concept of numbers. So 1, 2, 3, 4, that is b raised to power of 4. And then we have c multiplying by itself twice, that is c raised to power of 2. So that is b power 4, c raised to power of 2. Similarly, if we look at this, that is 1, 2, 3, 4, 5 zeros as powers of 10. So this is basically 10 multiplying by itself 5 times, because there are 5 zeros over here. So this can be written as 10 power 5. So indices makes life a lot easier. Now another question like this. Now you have to simplify the numerator and the denominator. So 2 over 5 raised to power of 2. So this power of 2 is applicable on the numerator, it's applicable on the denominator. So 2 is being squared, 5 is being squared, that is 4 over 25. For example, 1 part A. So in one part A, this is 1 over 2 raised to power of 2, which is 1 raised to power of 2, 2 raised to power of 2, which is 1 over 4. Similarly, if I focus on part G, that is 5 over 3 raised to power of 4. This is 5 raised to power of 4, 3 raised to power of 4, 5 raised to power of 4 is 625, 3 raised to power of 4 is 81. That is the answer for this particular part. Now, what are the different laws of indices? Now, first of all, over here, we are talking about this thing, that A is the base and we are taking M and N. These are the powers, these are the indices. So now first of all, let me categorize this thing. Let me focus on the first two things, that is this thing over here. So now over here, what I see is that we have a same base and these two rules are for multiplication and division. For example, a power m into a power n, that is a m plus n. That means if the bases are the same and its multiplication, the powers add up. Same base, multiplication process, powers add up. So remember the rule in words also, because you have to apply. You don't have to memorize as such, you have to apply. Similarly, if I look at the other rule, what is the other rule? That other rule is a power m divided by a power n, that is a m minus n. So now over here, I can say, yes, the base is still the same and it's about division. So this is multiplication. Let me write it. This is multiplication. And the n thing is powers add up. And over here, we are doing division. And the result is that the powers gets subtracted. Now let me focus on this and let me just copy this thing and let me paste it on the next page. So I'm just pasting it over here. I'll be using it soon. So let's focus over here. So now this first rule, the rule in red, what is this about? That is, let's say 2 power 3 into 2 power 2. That is 2 raised to power of 3 plus 2. That is 2 raised to power of 5, and I can even simplify it further. This becomes 32. Let's double check. 2 raised to power of 3 is 8. 2 raised to power of 2 is 4. 8 into 4 is 32. All good, all clear. Similarly, if I have 3 raised to power of 4 divided by 3 raised to power of 1, that is 3 raised to power of 4 minus 1, which is 3 raised to power of 3, which is 27. Also double check. 3 raised to power of 4 is 81. 3 raised to power of 1 is 3. 81 divided by 3, yes, it's 27. So the first two rules are perfectly good, perfectly clear. Now let me focus on this rule. I've used green color over here. Let me just focus on these two first. Now, if I focus on these two, a power 1 is a power 0 is 1. So a power 1 is a. That means if I write 2 raised to power of 1, that is simply the number itself. And a power 0 is 1. We take it for granted. But let me prove this. So how can I prove it? Let's prove this. Let's say 2 raised to power of 3 divided by 2 raised to power of 3. This is 8 over 8, which is 1. Can I write 2 raised to power of 3 over 2 raised to power of 3? That is 2 raised to power of 3 minus 3, which is 2 raised to power of 0. And naturally, these two things are exactly the same. So therefore, I'll say a raised to power of 0 comes out to be 1, quite easily done. That is how we have proven it. So now we have the first two rules. Then we have a raised to power of 1 is a, that is basic. A raised to power of 0 is 1. So now let me focus on this rule that is right over here. A raised to power of m raised to power of n, that is a raised to power of m into n. A raised to power of m raised to power of n, the powers multiply. So if raising to a power, let me write it like this, raising to a power, then powers multiply. And let me add a page. Over there, I'll be writing two other rules which are not written over here. So let me just make a box. Okay. So now coming back to this. Let me first write this thing, that is 2 raised to power of 3 raised to power of 2. According to this rule, that is 2, 3 into 2. That is 2 raised to power of 6, which comes out to be 64. I'll also list down a lot of these indices for you in a short while. Now let's double check. If I double check this thing, 2 raised to power of 3 raised to power of 2, 2 raised to power of 3 is 8, 8 raised to power of 2 is 64. Yes, this rule works. So of course, all these rules, they work, but it's just showing you with a lot of these examples. Now let me focus over here. This time a power m into b power m, that is equals to ab raised to power of n. So this time the rule is about same powers. It's not about same base. The base could be same or not. That's not the issue. It's about same powers. And let me write another rule. A power m divided by a power or b power m, then this equals to a over b raised to power of m. So now over here, let me write 2 power 3, or let me make it 2 power 2 into 3 power 2. That becomes 2 into 3 raised to power of 2, that is 6 raised to power of 2, that comes out to be 36. Let's again double check. So let's check. 2 power 2 into 3 power 2, 2 power 2 is 4, 3 power 2 is 9, 4 into 9 is 36. Yes, the rule works. Similarly, something like 4 power 4 divided by 2 power 4. So 4 power 4, that is 64 into 4, that is 256. And let me first use the rule. So this is 4 divided by 2 raised to power of 4. That is 2 raised to power of 4. That comes out to be 16. Again, let's check. 4 power 4 over 2 power 4, that is 256 over 16. 256 over 16 is 16. Yes, the answer is correct. So now I have gone over all these different rules of indices. Rules of indices in which base are the same. Multiplication gives rise to addition. Division gives rise to subtraction. A power 0 is 1. A power 0 is 1. A power 1 is A itself. This rule is on the next page. That is a power m raised to power of n. The powers multiply. And then if there are same powers, multiplication, take a power common, that is common in all of them. Let me first write. So let me write basis multiply, and then the power comes at the top. Over here, the bases, they divide and the powers come at the top. And that is the example for this. Now let's look at this question. It says simplify the following, leaving answers in index form. So we don't have to just solve it out. We just have to leave the answers in index form. Now 3 power 8 into 3 power 5, this is multiplication. So add the indices. So that is 3, 8 plus 5, that is 3 power 13. 10 power 8 divided by 10 power 5, this is about division. So that is 8 minus 5, which is 10 power 3. 2 raised to power of 7 raised to power of 2, 7 into 2 is 14. So some basic rules. Some examples related to this. Without using a calculator, simplify the following. Leave your answer in index form. Leave your answer in index form. Let me focus on part C. Let me focus on part G. Let me focus on K. Let me focus on M. And something like O, something like T, and something like P, and some division like R. So all these small examples, let me do them so that your vision is all good, all clear. So let's start with C. That is 2a power 6 into a power 4. A power 6 into a power 4. The bases are the same. Powers add up. A bracket 6 plus 4, which is a power 10. Something like part G. That is 7 into 7 power 6. 7 is basically 7 power 1. Because we know that a power 1 is a itself. So I have written 7 as 7 power 1. So therefore we have this thing 7, 1 plus 6, which is 7 power 7. Let me focus on K, which is 11 raised to power of 2 raised to power of 5. That is 11 2 into 5, which is 11 raised to power of 10. Let me try out M. That is F raised to power of 75 divided by F raised to power of 75 divided by F raised to power of 25. That is F 75 minus 25. That is F raised to power of 50. O. That is G power 11 raised to power of 8. That is G 11 into 8. That is G of 88. Something like P. And let me write it down. E power 12 into E power 3. Let me write down R 54096. R 17540 divided by 1796. And then we have F 14 power 7 raised to power of D. And that is not F, that is T. So I was just wondering how come there is an F after a T. Is there a new English alphabet or something? 14 power 7 raised to power of D. 14 power 7 raised to power of D. So over here in part E, the powers add up. That is E raised to power of 12 plus 3, which is E raised to power of 15. Over here, it's division. 17, 540 minus 96. 540 minus 100, that is 440, and add a 4 to it, 444. That is 17 raised to power of 444. And over here, the powers multiply. 14 raised to power of 7 into D. That is 14 raised to power of 70. So these are some basic worked examples that I've done for you. Something like this, the kind of reverse process. For each of the following, find the numbers that should replace the square. Now, let me try out A. Let me try out B. Let me try out D. And then P over here, and then N over here, and M over here. So 2 part A, 3 power 3 into 3 power 6, that is 3 raised to power of this box. So basically 3 raised to power of 3 plus 6 is 3 power box, 3 raised to power of 9 is 3 power box, So now since the bases are the same, the powers should be equal. So now the rule is same base, bases are the same. Therefore equate the powers. So when we equate the powers, therefore this box comes out to be 9. That is the logic that is applied over here. Let me focus on part B. Q raised to power of 8 divided by Q raised to power of 3, that is Q raised to power of this empty box. Q raised to power of 8 minus 3 is Q raised to power of box. Q raised to power of 5 is Q raised to power of box. Therefore, this 5 equals to this box. Therefore, the box equals to 5. Part D. 6 raised to power of 10 raised to power of 4 is 6 raised to power of this box. 6 raised to power of 40 is 6 raised to power of box. The bases are the same. The powers are equal. Therefore, this box is equals to 40. And let me take it to the next page so that I can comfortably work it out. And which ones have I marked? That is M, N and P. So that is M, N, P. Let me go to the next page. That is M and N and P. So let me focus on M. P raised to power of 7 raised to power of box is P raised to power of 49. That is P raised to power of 7 box. The powers multiply. That is P raised to power of 49. Since the bases are the same, the powers should equal. 7 empty box is 49. Therefore, empty box is 49 over 7, which comes out to be 7. Similarly, let me focus on N. That is 13 power 6 divided by 13 power box is 13 only. That is 13 power 1. 13 power 6 minus box is 13 power 1. Now over here, this power equals to this. 6 minus box is 1. Therefore, this box is 6 minus 1. Therefore, this box is 5. And the last part, 2 raised to power of box raised to power of 5 is 2 raised to power of 40. 2 raised to power of 5 box is 2 raised to power of 40. So therefore, this 5 box is 40, 5 box is 40, box is 40 over 5, which comes out to be 8. So these are some nice special questions that I've solved them. Now something more. In questions 3 to 4, simplify each expression without a calculator. So without a calculator, leave your answers in index form. So some basic kind of question. For example, 3 part A, 3 power 2 into 3 power 5 into 3 power 7. The powers add up. 2 plus 5 plus 7. That is 7 plus 7. That is 14. Let me first mark this. I'm marking part A. I'm marking part C. I'm marking part F. So now A is done. Let me focus on C. P power 6 raised to power of 2 into P power 5. Now it's multiple operations. So P power 12 into P power 5. This is P power 12 plus 5. This is P power 17. Something like part F. 8 power 3 into 8 power 7 divided by 8 power 9. Now two things are multiplying and one thing is dividing. And they all have a same base. So 8 multiplied with 3 plus 7, the powers add up, minus 9. 3 plus 7 is 10, 10 minus 9 is 1, that is 8 power 1. Leave the answer in index form. The same kind of scenario over here. So let me try out part E. Let me try out part I. Let me try out part F. And a symbolic part K. So now over here, we have part E first. So part E, that is S power 8 into S power 4 divided by S power 3 into S power 6. S power 8 plus 4, that is in the numerator, S into 3 plus 6 in the denominator, S raised to power of 12 s raised to power of 9. So now s raised to power of 12 minus 9, which is s power 3. So that's how I've done it. I've treated the numerator and denominator separately and then simplified. Part F, 2 power 5, 2 power 5 divided by 2 raised to power of 3 raised to power of 2. 2 raised to power of 5 plus 5 divided by 2 raised to power of 6, the powers multiply. 2 raised to power of 10, 2 raised to power of 6, 2 raised to power of 10 minus 6, which is 2 raised to power of 4. Let me copy this, take it on the next page. Now, which other ones were there? That is I and K. So let me just erase from here. And let me highlight over here. This is I, this is K. So in part I, this is 5 power 5 into 5 power 5 divided by 5 power 8 divided by 5 raised to power of 3. 5 power 5 plus 5 over 5 raised to power of 8 minus 3. That is 5 raised to power of 10. This is 5 raised to power of 5, which is 5 raised to power of 10 minus 5, which is 5 raised to power of 5. Part K. T power 6 divided by t power 3, the whole thing raised to power of 4. T power 9 divided by t power 4. The numerator t power 6 minus 3 raised to power of 4. Denominator t raised to power of 9 minus 4. Division, and then there is a power. T power 3 raised to power of 4. This is t raised to power of 5. 3 into 4 is 12 divided by t raised to power of 5. This is t raised to power of 12 minus 5, which is t raised to power of 7. Negative indices. Yes, something very, very important. A raised to power of negative m can be written in the reciprocal form as 1 over a raised to power of m. 2 raised to power of negative 2, that is 1 over 2 raised to power of 2, which can also be written as 1 over 4. 3 raised to power of negative 2, that is 1 over 3 raised to power of 2, that can also be written as 1 over 9. Now, let me join two things up. 2 over 3 raised to power of negative 2. Can I write this thing as 2 raised to power of negative 2? I can write this thing as 3 raised to power of negative 2. Now 2 raised to power of negative 2 is 1/4 and 3 raised to power of negative 2 is 1 over 9. So therefore this is 1/4 and its division, which is 1 over 9. Are you getting it? I'll be doing a shortcut. So 2 power negative 2 is 1/4. Then there is this division sign. 3 raised to power of negative 2 is 1 over 9. And after simplification, what does it become? So 1 over 4 into 9 over 1, which comes out to be 9 over 4. Got it? So now this is a very important example. So now the easy way is to remember this rule, that is a over b raised to power of negative m can be written as b over a raised to power of positive m. A very, very important rule, not only in O-level maths, not only in IGCSE, it's also important in P1 and P3 and M1 and S1 and S2, that is A-level maths. So these things are very, very important. That means if I write this is 2 over 3 raised to power of negative 2. 2 over 3 raised to power of negative 2. That can be written as, flip the fraction, 3 over 2 raised to power of positive 2. That is 3 raised to power of 2. That is 2 raised to power of 2, which is 9 over 4, which is exactly the answer over here. So just acknowledge on the WhatsApp if this is all good, all clear, and then I'll continue the journey. Now let's get started with this thing. So now we are starting with these simple examples. Write the following as fractions. So this is as fractions. 4 raised to power of minus 1. This is 1 over 4 raised to power of 1, which is 1 over 4. 5 raised to power of negative 3, that is 1 over 5 cube. 5 cube is 125. Write the following in the index form. Now this is a raised to power of negative m in the negative index form. 1 over 5 is 5 raised to power of negative 1. 1 over 11 is 11 raised to power of negative 1. 1 over 3 square is 3 raised to power of negative 2, and so on. And then it's asking about the fractions, which I have just used. A over b raised to power of negative m, that is b over a raised to power of positive m. So let me do part D. 5 over 2 raised to power of negative 3 can be written as 2 over 5 raised to power of positive 3. That is 2 raised to power of positive 3, 5 raised to power of positive 3, that is 8 over 125. Something like this. Simplify the following, and this is like algebra based. So there is something to do with algebra, there is something to do with the numbers thing. So now in this one, what exactly are we looking for? We are looking for this thing, that y power 5 divided by y cube. So I think this is pretty basic. Y power 4 divided by y power 3, which is y power 4 minus 3, which is y 1 over y cube. So let me just correct myself. I misread it in a hurry. Y power 4 divided by 1 over y cube divided by 1 over y cube. So I think I'll just write this thing as y power 4 into y power 3 over 1. This is y power 4 plus 3, which is y power 7. I think I'm getting at the same answer, but what they have done is that they wrote it as a negative index and then they worked it out. I think I'll just flip this thing. That is much easier. Similarly, if I have this thing, part B, z power 8 into z raised to power of 4 raised to power of negative 2. 4 raised to power of negative 2. Z power 8 into z raised to power of 4 and negative 2 multiply, which is negative 8. Z raised to power of 8 plus negative 8, which is z raised to power of 0, which comes out to be 1. Now, there are some other questions of the same format. Let me first mark them. So let me try out part E. Let me try out part F. Something like J. Something like N. Something like R. So let me try these out. Now, first of all, part E. This is h raised to power of negative 5 raised to power of negative 1. That is h raised to power of negative 5 into negative 1, which is h raised to power of 5. Part F. This is 2 power 16 divided by 1 over 2 raised to power of 4. That is 2 power 16 multiplying with 2 raised to power of 4 over 1. That is 2 raised to power of 16 plus 4, which is 2 raised to power of 20. I'm leaving the answer in the index form. Something like J. K power 10, K power minus 6, K power 10 into K power negative 6 divided by K power 0. K power negative 6 and then divided by K power 0. So I can right away say that K power 0 is 1. So just get rid of this. Division by 1 doesn't make a difference. K power 10 plus negative 6, that is K power 4. Something like N. 6 power negative 3 into 6 power 10 divided by 6 power 4 into 6 power negative 5. That is 6 power negative 3 plus 10. This is 6 power 4 plus negative 5. This is 6 power 7. This is 6 power negative 1. 6 power 7 minus 1, which is 6 power 8. And last one on this page are n power minus 4. Let me first write it down. N power minus 4 into n power nothing, which means it's n power 1. And this is n power negative 3 raised to power of 6. N power negative 3 raised to power of 6. N power negative 4 plus 1. N power negative 3 into 6. Go step by step. N power negative 3. N power negative 18. N power negative 3 minus 18, that is plus 18. 18 minus 3 is 15. That is the answer. Something like this. Evaluate. Give your answer as a fraction. You just have to do it separately. So 2 power 4 into 5 power negative 3. That is 2 power 4 is 16. 5 power negative 3 is 1 over 5 cube, that is 16, and this is 1 over 125, that is 16 over 125. Let me create another question. 3 raised to power of 4 into 7 raised to power of negative 2. 3 raised to power of 4 is 81. 7 raised to power of negative 2 is 1 over 7 square. This is 81. This is 49. That is 81 over 49. So this is example 5. That's right over here. And this is my example. That is example 6 or example 5 star. So that there is no confusion with any other worked examples. Okay. So now let's move ahead. Similar questions like this, nothing special. Yes, there is one thing that I want to emphasize. That is, when we square a number, a positive number remains positive. A negative number also becomes positive. And if we cube a number, so positive will remain positive and negative will remain as negative. So that is the thing. So therefore this is negative will remain negative, positive will remain positive. Now why am I saying this? Because I just saw this particular question. That's right over here. That is part G. So let me first focus on this. Negative 9 raised to power of 2 into negative 5 raised to power of negative 3. So now first of all, this is negative 9 raised to power of 2, that is 81. And this is 1 over negative 5 raised to power of 3. Now this thing right over here, this negative 3, hold for a second, let me use a green marker. This negative 3 becomes a positive 3 because I've taken it down. This negative will remain as it is. So therefore, this is 81 as it is. This is 1 over 125 with a negative sign. That is 81 over 125 with a negative sign. Something like part L. This is 3/4 raised to power of negative 1 divided by 1 over 2 raised to power of negative 3. That is 4 over 3 raised to power of positive 1 division by 2 over 1 raised to power of positive 3. This 4/3 will remain as 4/3 division as it is. 2 raised to power of 3 is 8 and this is 1. So 4/3 into 1 over 8. Now there are two things that have happened. The first thing that did happen, let me just focus on this. That is this thing that I have dealt with this power. This power that's right over here, I have made it positive. So that is why this fraction flips. This fraction flips. But this division sign remains as it is. As it is. And then in the end, this division sign changes into multiplication and then this flips. Now cancel it out. 4 1s are, 4 2s are. Therefore, the answer is 1 over 6. I'll just pause for a second. I want you to have a good look at it. All good? All clear? Fractional indices. Now, what are fractional indices? Fractional indices is like square root and cube root, something like that. So a raised to power of 1 over m. Now let me write it in the fractional form. A raised to power of half. This is square root of a. So this is square root. A raised to power of 1/3, that is the cube root. And a raised to power of 1 over m, that's the mth root or the nth root. So that is a, and n goes over here. Now, for example, we know that if I write 2 raised to power of 2 is 4, therefore 4 raised to power of half is 2 square raised to power of half. These two powers would multiply and I'm left with 2 raised to power of 1, which is 2. I'm just dealing with positive basis for right now. I'm just dealing with positive basis. So positive base raised to power of even number is giving me 4. So square root of 4 is 2. Yes, it's also negative 2, but I'm not dealing with a negative base. Similarly, if I write 2 raised to power of 3 is 8, therefore the cube root of 8, we know it's 2, but I'll write it in the index form 2 raised to power of 3 raised to power of 1/3. So this 3 and 1/3 will multiply. This is 2 raised to power of 1, which is 2. Got the idea? Now over here, the example is that of 27 raised to power of 2/3. So let me write over here. That is, hold for a second, let me get the marker correct, 27 raised to power of what? That is raised to power of 2/3. Now write 27 as 3 cube. So 3 cube raised to power of 2/3. The powers multiply, this 3 will cancel with this. We are left with 3 raised to power of 2. 3 raised to power of 2 is 9. Let me explain this thing. Rewrite the following expression in this form or in this form. Now, first of all, this I need to focus a lot. Part A, question number 1, a raised to power of 1/5. That can be written as the root sign, a inside and 5 on the outside. That means it's the 5th root. Part B, a raised to power of 1 over 8 can be written as the root sign, a inside, 1/8, that is the 8th root. What about part C? A raised to power of 3/5 can be written as a raised to power of 3 raised to power of 1/5. That is a cube on the inside and power 5th on the outside. So basically it means the 5th root of a cube. Got the idea? The 5th root of a cube. Why? Because we have this rule, a power mn can be written as a power m raised to power of n. It can be written as a power n raised to power of m, because eventually these two powers will multiply. So if this is 3/5 over here, 3/5 can be written as 3 into 1/5. So I have written this 3 on the inside and I'm dealing with fractional power. So that fractional power comes on the outside. Is this all good? All clear? Let me do some more. Part D. A raised to power of 2/5. That can be written as a raised to power of 2 raised to power of 1/5. That is a square on the inside and the 5th power on the outside. Part E. E raised to power of, no, in part E, the base is a raised to power of 5 over 2. That is a raised to power of 5 raised to power of half. That is the square root of a raised to power of 5. There's no need of writing a 2 over here. A simple square root means power of half. So now this is all good, all clear. Now let me just copy this thing, paste it on the next page, and let's focus on this one. So now the question says, let me highlight this thing. Evaluate the expressions given in questions 2 to 3 without using a calculator. So there is this thing and there is this thing. This is the 3 that they are talking about. So let's focus on this. So now over here, let's write part A, 64 raised to power of half. 64 raised to power of half. I can write 64 as 8 square raised to power of half. That is 8 raised to power of 1. Why? Because 2 and half will multiply. I'm left with 1 and the answer is 8. Something like part C, 64 raised to power of 1/3. That is 4 cube raised to power of 1/3. That is 4 raised to power of 1, which is 4. Something like question number 3, part A. 125 raised to power of 2/3. That is 5 cube raised to power of 2/3. That is 5 raised to power of 2, which comes out to be 25. Over here, this 3 and this 3 will cancel out. 5 raised to power of 2, which is 25. Something like E. That is 32 raised to power of 3/5. 32 is 2 raised to power of 5 raised to power of 3/5. This is 2 and 2, 5 and 5 will cancel out. 2 raised to power of 3, which comes out to be 8. Before we proceed, let me draw some important boxes for you, important values for you. Now, first of all, 2 raised to power, that's too thick. So now 2 raised to power of 1 is 2, 2 raised to power of 2 is 4, 2 raised to power of 3 is 8, 2 raised to power of 4 is 16, 2 raised to power of 5 is 32, 2 raised to power of 6 is 64, 2 raised to power of 7 is 128, 2 raised to power of 8 is 256, and 2 raised to power of 9 is 512, and 2 raised to power of 10 is 1024. These are some common ones that usually comes. Now we know that 2 raised to power of 2 is 4. So let me focus on 4. 4 raised to power of 1 is 4. So let me write it over here. 4 raised to power of 1 is 4. 4 raised to power of 2 is 16. 4 raised to power of 3 is 64. 4 raised to power of 4 is 256. 4 raised to power of 5 is 1024. Do you see the linkage that I have drawn? The linkage that I have developed is this thing. 2 raised to power of 2 is 4. That's the same thing as 4 raised to power of 1. 2 raised to power of 4 is 4 squared. 2 raised to power of 6 is 4 cube. 2 raised to power of 8 is 4 power 4. 2 raised to power of 10 is 4 raised to power of 5, because 4 is already the double of that. Let me add a page more. Let's deal with 3. 3 raised to power of 1 is 3. 3 raised to power of 2 is 9. 3 raised to power of 3 is 27. 3 raised to power of 4 is 81. And 3 raised to power of 5, that is 340 into 3, that's 243. Not 343, that's 243. Do double check. Similarly, if I talk about 5, 5 raised to power of 1 is 5, 5 raised to power of 2 is 25, 5 raised to power of 3 is 125, 5 raised to power of 4 is 625. Let's talk about 6. 6 power 1 is 6, 6 power 2 is 36, 6 power 3 is 216. Let's talk about 7. 7 power 1 is 7, 7 power 2 is 49. What is 7 power 3? 7 power 3 is 343. Okay, so now these are the common ones that you need to remember. And let's move ahead. And basically, as far as the concept is concerned, we are thoroughly done with the concept. Now let me just pick some past paper questions from here, from the topical book. And let me try out this particular question, these two questions, and the topical book will soon be available and you can try out these questions from there. So let me just put it over here, and let me also add another page, that is this one. So now over here, okay, now let's continue with this. It is given that 5 raised to power of negative 2 into 5 raised to power of k is 1. Write down the value of k, the first thing. Then the second part that I'll do on the sidelines over here. So part A, 5 raised to power of negative 2. Let me make the marker thinner, that's too thick. Okay. 5 raised to power of negative 2 into 5 raised to power of k is 1. 1 can be written as 5 power 0. A power 0 equals to 1. So I'm dealing with the same base over here. Therefore, 5 raised to power of negative 2k is 5 raised to power negative 2 plus k. The powers add up is equals to 5 power 0. So therefore, focus on this one. So let me just focus. That's this and this are equal. Therefore, minus 2 plus k equals to 0. Therefore, k comes out to be positive 2. So k comes out to be positive 2 for 1 mark. The next one, part B. 7 raised to power of 3, 1/3, because that's a fractional indices. 7 raised to power of 1/3 is 7 raised to power of m. So therefore, the bases are the same. The powers should equal. So therefore, I'll write m is equals to 1/3. So that is very, very basic. So this is the kind of question that's done. Something like this. Let's get started with this. So first of all, that's part A. It says 3, let me just do it over here. So part A, that is 3 power A divided by 3 power 5 is 27. That can be written as 3 cube. So therefore 3 power A minus 5 is 3 power 3. The powers should be equated. Therefore A minus 5 is equals to 3. Therefore A comes out to be 8. That thing is done. Let's focus on part B. 125 power B is 5. So now let me focus over here, part B. 125 power B is 5 power 1. 125 is 5 cube raised to power of B is 5 power 1. 5 raised to power of 3B is 5 raised to power of 1. The bases are the same. The powers should equal. Therefore 3B equals to 1. B is 1/3. And there is also another way of looking at it. The cube root of 125 is 5. Why? Because the cube of 5 is 125. We just went over this thing. That's right over here. 5 cube is 125. The cube root of 125 is 5. So that is one other way of understanding this, but we have to break it down to the basics. Now let me focus on part C. That's right over here. So let me focus on part C. It says 10 raised to power of C, that is 0.001. Now 0.001, let me play with the decimals 1, 2, 3. That is 1 over 1000. That is 1 over 10 cube. That is 10 raised to power of negative 3. So therefore, I'll write 10 power C is 10 raised to power of negative 3. Since the bases are the same, the powers should equal. Therefore, C comes out to be negative 3. So C comes out to be negative 3. So that is a wholesome lecture, which is lecture number 23 of algebra. So now we have understood the concept of indices thoroughly. Whether it's indices related with numbers, whether it's indices related with algebra. So this thing is done and dusted. So till the next class, take care.